press the bell icon on the YouTube app and never miss another update.
Hello children, in the previous class what we were seeing? We have seen the topic that is motions of earth, and in that we have seen that there are two motions of earth, that is rotation and the revolution. So with this what we can get? In the previous class we have known about the rotation of earth, that is earth rotates around its own axis within 24 hours. So that period, 24-hour period, we call that as a earth day. So that is the motion of earth in a day. Now we are going to see about the another motion, that is the revolution. So we are going to see about the revolution. Can you see this? So we are going to study about the another motion or a movement of earth, that is revolution. In the previous class we have seen that revolution means the movement of earth around the sun in a fixed path. So we'll see the rest in here. The second motion of the earth around the sun in its orbit is called as a revolution. It takes 365 and 4 days, 1 year, that is nearly 1 year to revolve around the sun. We consider a year as consisting of 365 days only and ignore the 6 hours for a sake of convenience. 6 hours saved every year are added to make 1 day, that is 24 hours, over a span of 4 years. This surplus day is added to month of February. Thus, every 4th year, February is 29 instead of 28 days. Such a year with 360 days is called as a leap year. Find out when will the next leap year be. From the figure 3.3, it is clear that Earth is going around the sun in an elliptical orbit. Notice that throughout its orbit, the Earth is inclined in the same direction. A year is usually divided into summer, winter, spring and the autumn season. Seasons changes due to the change in the position of Earth around the sun. So, we will see here. Here they have given a picture. I will write that on a board. So this is the sun. Okay. Here earth. Here also earth. Here also it is earth. Here also it is earth. Okay. So this is the sun and this is the earth surface. This is the earth surface. This one too. Okay. Why I have drawn this line? This is the axis of earth. Earth. Let us imagine here they have given. This is the spring and this is also a spring. Winter in the northern hemisphere. Winter solstice, okay, summer in the southern hemisphere and winter in the southern hemisphere and the summer in the northern hemisphere. Okay, this is autumnal and this is autumn. Okay, now what we are going to do? This is the sun, this is the earth. Let us start from here. Imagine here earth is here and you see that this earth is slowly moving around the sun in a fixed path. Okay, so this earth is moving around the sun in a fixed path. This earth is moving around the sun in a definite elliptical path. Okay, so this earth here, this is the sun, it will give the radiations like this on the earth's surface. So we have now this is the axis, and this is the south pole and this is the north pole, right? So this is the northern hemisphere and this is the southern hemisphere. Okay, so the part which is towards the sun will receive the light. That is why here this on 21st or what 23rd September it will be autumn. On 23rd September here this period it will be autumn, and here it will be spring. It will be spring. Okay, so on this 23rd September this part will experience as the autumn and this part will experience as the spring. Okay, and here this is also a south pole, that is southern hemisphere, and this is the north and this northern hemisphere. And so this part will receive the light. Okay, that is why what will happen, this southern hemisphere will receive a light, there it experiences the summer, and this northern hemisphere experiences the winter. Similarly here it is autumn and this side it is spring, and here this northern hemisphere will experience the summer and southern will experience the winter. Here I cannot show this clearly in a diagram because it is very short. You can see here in the textbook they have given it very clearly. Okay, where and all the summer and the winter we experiences. The portion which is towards the sun will experiences the heat. The other portion which is away from the sun will experiences the cold. Understood? Okay. So this is how the earth moves around the sun in a fixed orbit. So this is known as a revolution, and starting from here it will cover, and to come here it will take 365 and 6 hours and 1/4, that is 365 days plus 6 hours. So we consider 365 as a year, as a 1 year. So for 1 year and 6 hours our earth will complete 1 revolution. Okay, for 365 days and the 6 hours our earth will complete 1 revolution around the sun in a fixed path. But we take 365 as a 1 year because it is not convenient to say 6 hours. That is why what we will do, we take 365 for the 1 year. 1 year means we take 365 days. And this 6 hours, what we will do, we will join the 6 hours. Okay. So for 1 year it is 365 plus 6 hours, and for second year it is 365 plus 6 hours, and for third year it is 365 and 6 hours, and for fourth year 365 plus 6 hours. Okay, so we will join all these 6 hours. What it will become? It will become a 24 hours, that is 1 day. So we will take that 1 day extra in a February month after the 4 years. Understood? So what we will do, Earth take 365 plus 6 hours to complete the one revolution, but for our convenience we take the 365 as a 1 year and the remaining 6 hours, that is added to a 4 hours, 4 years to make a 24 hours. So this one day, extra one day, which is made by adding all these 6 hours, that will come on a February. Usually February will have a 28 days, but after 4 years it will have a 29 days. That year where we get a one extra day in a February, that year we call it as a leap year. What we call it as? We call it as a leap year. So this is somewhat difficult. Let me, not difficult, is complicated. So let me explain this in Kannada. ಏನಾಗುತ್ತೆ, ಇದು ನಮ್ಮ ಭೂಮಿ. ಈ ಭೂಮಿ ಸೂರ್ಯನ ಸುತ್ತ ಒಂದು ರೌಂಡ್ ಸುತ್ತ ಬರೋದನ್ನ ಒಂದು ರೆವಲ್ಯೂಷನ್ ಅಂತ ಕರಿತೀವಿ. ಹೌದಾ? ಓಕೆ. ಈ ಭೂಮಿ ಏನು ಮಾಡುತ್ತೆ, ಇದು ತನ್ನ ಸುತ್ತುತ್ತಾ ಇರುತ್ತೆ. ತನ್ನ ಸುತ್ತಲೂ ಸುತ್ತೋದಲ್ಲದೆ ಜೊತೆಗೆ ಹಿಂಗೆ ಸುತ್ಕೊಂಡು ಈ ಸೂರ್ಯನ ಸುತ್ತಲೂ ಸುತ್ತಿ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. ಇದು ಈ ಥರ ಪೂರ್ತಿ ಸೂರ್ಯನ ಸುತ್ತಕೊಂಡು ಬರೋದಕ್ಕೆ 365 ದಿನ ಪ್ಲಸ್ 6 ತಾಸು ತಗೊಳುತ್ತೆ. ಆದರೆ ನಾವು ನಮ್ಮ ಕನ್ವೀನಿಯನ್ಸ್ಗೆ 365 ದಿನ ಮಾತ್ರ ತಗೋತೀವಿ, ಆ 6 ಅವರ್ಸ್ನ ಬಿಡ್ತೀವಿ. 1 ಇಯರ್ಗೆ 365 ದಿನ ಇದೆ ಅಂತ ನಾವು ಕನ್ವೀನಿಯೆಂಟ್ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೋಸ್ಕರ ಇಟ್ಕೋತೀವಿ. ಉಳಿದಿದ್ದ 6 ಅವರ್ಸ್ನ ಏನು ಮಾಡ್ತೀವಿ ಹಾಗಾದರೆ? ಉಳಿದಿದ್ದ 6 ಅವರ್ಸ್ನ 4 ವರ್ಷ, ಈಗ ಒಂದು ವರ್ಷದ್ದು 365 ಪ್ಲಸ್ 6 ಅವರ್ಸ್, ಇನ್ನೊಂದು ವರ್ಷದ್ದು 365 ಪ್ಲಸ್ 6 ಅವರ್ಸ್, ಮತ್ತೊಂದು ವರ್ಷದ್ದು 365 ಪ್ಲಸ್ 6 ಅವರ್ಸ್, ಇನ್ನೊಂದು ವರ್ಷದ್ದು 365 ಪ್ಲಸ್ 6 ಅವರ್ಸ್. ಈ ಥರ 4 ವರ್ಷದ್ದು 6 ಅವರ್ಸ್ 6 ಅವರ್ಸ್ 6 ಅವರ್ಸ್ 6 ಅವರ್ಸ್ನ ಕೂಡಿಸ್ತೀವಿ. ಆವಾಗ ನಮಗೆ 24 ಗಂಟೆ ಆಗುತ್ತೆ, ಅಂದರೆ 1 ದಿನ. ಸೊ 4 ವರ್ಷ ಆದಮೇಲೆ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಫೆಬ್ರವರಿಲಿ 1 ದಿನ ಎಕ್ಸ್ಟ್ರಾ ಮಾಡ್ತೀವಿ. ಅದನ್ನು ನಾವು ಆ ವರ್ಷ ಯಾವುದರಲ್ಲಿ ಫೆಬ್ರವರಿಲಿ 1 ದಿನ ಎಕ್ಸ್ಟ್ರಾ ಬಂದಿರುತ್ತಲ್ಲ, ಅಂದರೆ 28 ಡೇಸ್ ಬದಲು 29 ಡೇಸ್ ಬರುತ್ತಲ್ಲ, ಅದನ್ನ ನಾವು ಲೀಪ್ ಇಯರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ ರೆವಲ್ಯೂಷನ್. ಮತ್ತು ದ ಪೋರ್ಷನ್ ಸನ್ ಕಡೆ ಇರೋದು ಹೀಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡುತ್ತೆ. ಅದೇ ರೀತಿ ಸುತ್ತ ಹಿಂಗೆ ಹೋದಾಗ ಉಳಿದಿದ್ದ ಪಾರ್ಟು ಯಾವುದು ಸನ್ ಕಡೆ ಇಲ್ಲದೆ ಇರುತ್ತೋ ಅದು ವಿಂಟರ್, ಅಂದರೆ ಚಳಿಗಾಲ ಮಳೆಗಾಲ, ಅದನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡುತ್ತೆ. ಸೊ ಈ ಥರ ಒಂದು ರೆವಲ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಓಕೆ. ಸೊ ಅರ್ತ್ ವಿಲ್ ಮೂವ್ಸ್ ಅರೌಂಡ್ ದ ಸನ್ ಇನ್ ಅ ಎಲಿಪ್ಟಿಕಲ್ ಆರ್ಬಿಟ್. Okay, and it takes 365.6 hours to complete one revolution. Now look at the picture 3.3. You will see that on the 1st June the northern hemisphere is tilted towards the sun. So let me explain the seasonal variation, how that season variation will happen because of the revolution of a sun. So we'll see now how the seasonal variation will happen. So this is the sun, earth axis, earth axis, earth axis, earth axis. So earth is moving like this. ಇವೆಲ್ಲ ಮತ್ತೆ 4 ಅರ್ಥ ಅನ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ದೀರಾ, ಒಂದೇ ಅರ್ಥ ಹಿಂಗೆ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ನಾವು ತೋರಿಸ್ತಾ ಇರೋದು ಅಷ್ಟೇ ಅದು. ಓಕೆ. ನೌ ಯು ಸಿ ದ್ಯಾಟ್ ಆನ್ ದ 21st June, ಓಕೆ, 21st June, here 21st June, what will happen? The northern hemisphere is tilted towards the sun. This is the northern hemisphere. This is tilted towards the sun. Okay. The rays of the sun fall directly on the Tropic of Cancer. So this northern hemisphere, it is tilted towards the sun. So the rays will fall on this Tropic of Cancer. As a result, these areas receive the more heat. So, this area will receive the more heat. Then, the areas near the poles receive less heat as the rays of the sun are slanting. So, the rays of the sun are very slanting like this. The rays of the sun, they are slanting like this. Okay. So, what will happen at the poles? Here this is a pole. Okay. At these poles, near these poles, it will be very cold. Here also it is very cold because rays of the sun will be like this slanty, which falls on a tropic of Cancer. This region will be very heat. But the poles will be very cool because that won't receive the sun rays, because they will be in a slanty manner. Okay. The North Pole is inclined towards the sun and placed beyond the Arctic Circle, experiences the continuous daylight about 6 months. So, this North Pole will experiences the daylight about the 6 months. Okay. About the 6 months. Then it is summer in this, where I have left, experiences daylight about 6 months. Since a large portion of a northern hemisphere is getting light from the sun, it is summer in this region. Okay, north of the equator. So here it will be equator here, and this portion it is tilted towards the sun. So this northern hemisphere will be summer about 6 months, because it is receiving a heat here, that because of that this portion will be summer about 6 months. Okay. The longest day and the shortest night at these places occur on a 21st June. So here the longest day and the shortest night will happen. So here the longest day and the shortest night will happen at the 21st June. And this time in the southern hemisphere, all these conditions are reversed. It is winter season there. The nights are longer than the days. This position of the earth is called as a summer solstice. Okay, let me explain by taking only this earth surface, because then you can get it easily. So this is the sun and this is the earth. Okay, that is the earth. This is the axis. Here it is the equator, it is the north pole, and this is the south pole. So heat rays are slanty like this. That is why, except this pole part, this tropic of Cancer and all this part will receive the heat from the sun. It will be summer here on 21st June. And on this 21st June, here in the northern hemisphere, we experiences the longest day and the shortest nights. Similarly, it is dead opposite in the southern hemisphere. In the southern hemisphere, it will be winter here at this 21st June. Here it is opposite, that is longest nights and the shortest days. But here it is the longest days and the shortest nights. But here on the same day, 21st June, it is the longest nights and the shortest days. So this variation, this is known as a summer solstice. Okay. This position of earth is called as a summer solstice. So the earth in this position on the 21st June, what it experiences on the northern hemisphere, it experiences extreme heat, and the heat, but in the southern hemisphere it experiences the extreme cold, that is winter. So here it is longest nights, but here longest days. This position of earth on a 21st June, we call that is as a summer solstice. Solstice. We call that as a summer solstice. Okay, so we call this position of a earth on a June 21st, which experiences the northern hemisphere, which experiences the summer, and the southern hemisphere which experiences the winter, where in the northern hemisphere the days are longer and in the southern hemisphere the nights are longer. This earth's position on the 21st June, we call that as a summer solstice. Then on the 22nd December, so this is about the 21st June. Now this is sun and here it is earth, here it is the axis. Okay, on the 22nd December, here we can see okay, so this is the heat rays. On the 22nd December, the Tropic of Capricorn, here the Tropic of Capricorn, this is the equator, Tropic of Capricorn falls here. Okay, so on the 22nd December, this Tropic of Capricorn will receive the heat. That is why this southern portion will be summer and this northern portion will be winter. Understood? At 22nd December, here this Tropic of Capricorn will receive the heat from the sun. Tropic of Capricorn lies in the southern pole, in the southern hemisphere. We have seen that in the previous class. So this Tropic of Capricorn will receive the sun rays and this southern portion will be summer and this northern portion will be winter. Then, okay, this Capricorn of Cancer will receive the light. Okay, south pole tilt towards it. As the sun rays falls vertically at the Tropic of Capricorn, a larger portion of the southern hemisphere get light. Therefore, it is summer in the southern hemisphere with the longer days and the shorter nights. The reverse happens in the northern hemisphere. This position of earth is called as a winter solstice. Okay, so similarly in the 22nd December, this Tropic of Capricorn will receive the light and this southern portion, southern hemisphere will tilted towards the sun. So this part will receive the light. So here it is summer and the longer nights, and the northern part will be winter, will have a longer, here it is longer days and here it is longer nights. So this is known as a winter solstice. This is known as a winter solstice. Okay, so this is known as a winter solstice. The position of earth in the 22nd December will be like this. So this is known as a winter solstice. Then, do you know the Christmas is celebrated in Australia in summer season? So we celebrate the Christmas on a 25th December, that is in a winter season. But in Australia, it is celebrated on a summer season. On 21st March and September 23rd, direct rays of the sun fall on the equator. At this position, neither of the poles tilted towards the sun. Okay. So the whole earth experiences equal days and the equal nights. This is called as a equinox. So what will happen? So this is the sun and this is earth. This is also earth. Like this. Okay. 21st March and here 23rd September. This is the equator and this is the equator. See here. Here on 21st March and the 23rd September, neither of the poles will be tilted towards the sun. ಯಾವ ಪೋಲ್ಸ್ ಕೂಡ ಸನ್ಗೆ ಟಿಲ್ಟ್ ಆಗಿರಲ್ಲ. ಹಾಗಾಗಿ ಸನ್ ರೇಸ್ ಡೈರೆಕ್ಟ್ ಇಕ್ವೇಟರ್ ಮೇಲೆ ಬಿದ್ದುಬಿಡುತ್ತೆ. ಆವಾಗ ನಮಗೆ ಈಕ್ವಲ್ ನೈಟ್ಸ್ ಮತ್ತೆ ಡೇಸ್ ಆಗುತ್ತೆ. ಸೊ ಹಿಯರ್ ವಿ ಫೈಂಡ್ ದ ಈಕ್ವಲ್ ಡೇಸ್ ಅಂಡ್ ದ ನೈಟ್ಸ್. that is we call it as a equinox. This equal nights and the equal day, that we call it as a equinox. So this equal nights and the equal days at 21st March and the 21st September, that we known as a equinox. Here neither of the poles will be tilted towards the sun. So the whole surface of the earth, equators, everything will receive the light. So here we experiences the equal nights and the days. This is known as a equinox. On 23rd September, it is autumn season in the northern hemisphere and spring season in a southern hemisphere. The opposite in the case of 21st March. So on this 23rd September, on the northern hemisphere it will be autumn, and here on the southern hemisphere it will be a spring. Similarly, it is opposite to this here. Here this will be autumn, that is southern hemisphere will be autumn and the northern hemisphere will be spring season. So this is about the thing. When it is spring in the northern hemisphere and autumn in the southern hemisphere, okay. Thus you find that these three are days. Okay, thus you find there are days and nights and changes in the season because of the rotation of the revolution of the earth respectively. So we have seen the changes in the night and day, and the sum of the seasons as well are because of the revolution of this earth surface on the sun and also rotation of the earth around itself. So now we have seen that the changes in the season as well as the day and night changes, they are because of the rotation and the revolution of a earth surface around its own axis and around the sun as well. So till now we have seen that the revolution of a earth, that is on the 21st June we can see the summer solstice, and on the which day that is on the 21st June on the we can see that summer solstice, and similarly on 22nd December we see a winter solstice in this side, and also similarly we can see the equinox at 23rd September and the 21st March. So on 21st June we see the summer solstice, and 22nd December we see the winter solstice, and 21st and 23rd September we see the equinox. And days change in the night and day and winter summer season, everything depended upon the rotation as well as the revolution of a earth surface around the sun. So till now we have seen that the important motions of earth, that is the rotation as well as the revolution. We have seen that rotation means movement of earth around its own axis, revolution means movement of earth around the sun. So we have seen equinox, that is equal day and nights, and we have seen longest day and night, longest nights and days, everything in this chapter. So we'll see each other in a next classes with a next chapter. Till then you should read this carefully and understand everything. You can ask me doubt if you didn't get anything. Thank you.